Welcome all of you, and thank K&L Gates for the space, which is very nice. I'm Dick Reisman from Teleshuttle Corporation, which is my own company, and I'm co-chair of the program committee for the MIT Enterprise Forum, which is co-sponsoring the event with LES. So just a quick word about MIT Enterprise Forum. Basically, we're open to anybody. You don't have to be from MIT. We're aimed at helping entrepreneurs figure out how to start businesses and connect with investors and other people who can help them, and those other people connecting with the entrepreneurs. I think this is our last event for the spring. Our fall calendar includes, in September, New York City as a tech mecca, additive manufacturing and 3D printing across wide industries, which I believe is actually another joint LES event. Then we've got one of our own that's planned, which is $1 billion UX, which is user experience for those of you who don't know, and how UX has become the key to massive product valuations and exits. We have a think tank event, which is one of the formats we're doing, which is, it's been called a seance. It's basically, we don't have any panelists or moderators. We just sort of lead. We get a bunch of experts and a fairly expert audience to talk about the future of X. In this case, it's the future of retail. We've done one on TV and one on advertising that were well received. Not listed in the sheet you have is we expect to do a startup showcase, I think in September. We're not sure of the date yet. And there's some a number of other events in planning, so it'll be a good fall. So with that, I'd like to turn it over to Barbara Sawitsky of LES to introduce it for LES.
Thank you. Good evening. I want to welcome you all here to the joint meeting. This is the first LES and the MIT do 2 joint meetings a year. As Rich said, we'll be doing one in September again. I'd like to remind you that in August, LES has a meeting with the New York Biotech Association. It's basically a large networking event on the roof of the Bryant Park Grill. So mark a date in August, and I'm sorry I don't have it here, but if you're on our mailing list, you'll receive an invitation. It's a really great networking event, and you can watch everybody do yoga on the great lawn of Bryant Park while you're drinking. I'd like to introduce Eric Viera. Eric and I have worked together in various lives through the past few years, and Eric is a technology and business development consultant with extensive experience in life science and technology development. He is currently at CUNY, the City University, and he's the Director of Special Research Programs there. In addition to working with MIT, he and I also work together with a number of other people in this room with the Entrepreneurship Lab for NYC, which is supported by the New York City Development Economic Corporation. And Eric runs that program with the private contractor the city has. And I speak and I do some mentoring there. And if you're interested in mentoring young entrepreneurs, maybe you should contact Eric or I. It's a very, very exciting program. So with no further introduction, Eric.
Thank you. All right, thank you. Thanks to our programming partners, the LES of New York City, and obviously, again, our thanks to our host, K&L Gates, for this lovely venue and the reception. Yes?
What's LES?
Licensing Executive Society. Sorry.
Which rules the world.
There you go. If you'd like to learn more, you can go to their website, les.org, I believe. But I want to set the tone for tonight, and thank you all for coming out. We chose this topic because it's obviously been in the news a lot, and obviously with the turnout tonight, it's of interest to many of you in all different disciplines. So thank you for taking the time on this beautiful night to come out to our event. 2 years ago, LES and MIT actually collaborated on another event called the Age of Big Data in the Biosciences, where we discussed in this very room the implications and challenges facing life science and health science practitioners. Much of the discussion dealt with how to manage the data, how to protect the data, how to access the data. We touched a bit on privacy and intellectual property issues, but this was all very new territory for a lot of us. We discussed how New York City is a prime location to lead the nation into this new era of efficient, cost-effective healthcare, given that it is home to a large number of the world-class academic institutions, some of which are represented here today. It has the highest concentration of hospital beds in the country, and of course has the most ethnically diverse population in the world. In those 2 years, we have seen tremendous efforts put forth by our academic institutions, local and state governments, industry, nonprofit organizations. We now have the New York Genome Center, very active research and clinical programs both at Memorial Sloan Kettering, Cornell, NYU, Columbia, Mount Sinai, each tapping into this vast and rapidly emerging collection of human health data. So we're collecting and we're compiling huge amounts of data. So we truly have entered the age of big data, one spurred by the fact that storage has become extremely cheap. Instead of deleting emails, we keep them. Instead of writing down ideas on cocktail napkins, which will eventually end up in a landfill, or sopping up a spilled drink, they are tweeted. It has been suggested the entire collection of all music ever created can fit on a $500 storage device. The human genome, with its 3.2 billion base pairs, took 10 years and $1 billion to decode back in the late 90s and early 2000s, can now be read in a couple of days for less than $10,000, and we're closing in on the illustrious $1,000 mark. Facebook knows who our friends are, Amazon knows what we buy, Google knows what we search for. But the question remains today, how do we best deal with this deluge of data? How do we make use of the data to make better informed decisions? How do we effectively separate, in essence, the signal from the noise? How do we become smarter at what we do? What I came away from the last meeting 2 years ago is that what we are dealing with in the life science and health care space, which I have a lot of experience in, is very similar to many industries that are accumulating data. It could be financial data, human behavioral data, purchasing data. Today I'm excited to moderate this follow-up discussion from that event as we learn and discuss and hopefully gain clarity on how to approach these data repositories, how to gain insights from large data sets, and how we become smarter about what we do, how we do it, and what makes sense for our society as a whole. So we brought together experts in the field, and not just one field, but a few. So to my left here is Tony Berkman. He has a degree in computational finance from Carnegie Mellon University, and over 20 years experience on Wall Street. I consider him a pioneer in sourcing large proprietary data sets and using them to inform investment decisions. He led a large investment research team and now makes investment decisions for a New York City-based hedge fund, and he was one of my previous bosses. So, Natalie Jackson, she has a degree in political science from the University of Oklahoma, and further advanced training in statistical methods and survey methodology, and has recently joined the Huffington Post as a senior data scientist on the political team, or pollster team. I'm sure she'll elaborate more on how she's going to help the Huffington Post call future political elections or correctly gauge national sentiment on various issues. Next to her is Samir Maskey. He has a degree in computer science from Columbia University and recently launched a startup in New York City focused on applying machine learning techniques. He's also an adjunct faculty at Columbia University, where he teaches, among other things, methods in machine learning processes and technology entrepreneurship. And finally, Chris Wiggins. He's a degree in theoretical physics from Princeton University, is an associate professor in applied math at Columbia University, a founding a member of the Institute for Data Science and Engineering and the Department of Systems Biology, all at Columbia University. And if he didn't have enough to do, he's recently been tapped as New York Times Chief Data Scientist. So I think we have a great panel tonight. So I'm excited to be able to bring these folks to you so we can learn more. So what I always like to do is, because we do have a mixed audience, and this is such a new topic, not only big data, but this idea of data science. What we heard, and some of you may have read, Tom Davenport and Vijay Patil had written a Harvard Business Review article maybe less than a year ago, calling data scientists is the sexiest job of the 21st century. So what I'd like to learn, and maybe we can start off with Chris, is really what makes data science so sexy for Tom Davenport and Vijay Patil, who actually was the chief data scientist at LinkedIn, to make these kind of comments. So,
so DJ's done a lot for that, personally, actually. So DJ, when he was at LinkedIn, along with Jeff Hammerbacher, when he was at Facebook, started using the term data scientist as a job description. So they were trying to hire people who knew how to make sense of the really large data sets that they were gathering at Facebook and LinkedIn. And they were big, messy, and these are not data sets generated in the course of some natural experiment. These are what they like to call data exhaust. So abundant data, but not data that's generated by some carefully controlled experiment. It's simply the set of all interactions with Facebook, or the set of all interactions with any website. So they started using that term data scientist, and it really took off after around 2008 or so. It also really took off in academia, which I think had long been primed for something at the intersection of statistics and computer science. And in fact, although a less celebrated usage of data science was actually in the computational statistics community in 2001, there was a great paper which doesn't get cited very much by a statistician named Bill Cleveland, now at Purdue, proposing a new field called data science. And if you go back and read what he's describing, it's a lot like what we now call data science. It's the ability to take real-world problems posed to you by people who aren't necessarily statisticians, reframe those questions as computational statistical tasks, learn something, and then communicate back to somebody from the domain what you learned from that task. So to do that, you need the ability to have some statistical modeling, some sort of mathematical sense about how we build mathematical models of the world, some deep computational skills in order to deal with abundant data, and the ability to respect or at least listen to people from some domain so that you can reframe their questions as statistical or machine learning tasks.
Samir, do you want to add any comments to that? In your own domain and how you've entered into it?
So the particular domain I work on is natural language processing, which is just lots of amount of noisy text that could be generated in customer interactions or Facebook posts and whatnot. When you're trying to process noisy text, like what Chris said, you're trying to come up with statistical models which try to find information units, which we like to call features, extracted from those sentences, and then do something with it so that outcome is some sort of models or numbers that could be used for decision-making process within the company.
And what has changed over this time? You know, we obviously, the advent of data scientists and the need for data scientists, as they say, it's a growing field in employment category. Is it because of this deluge of data and we don't know how to handle it correctly? Because it's obviously impacting many industries.
So there's a handful of technology changes, but there's also sort of a sociological or mindset change. So the technological changes, one from maybe a decade or two ago is really high quality open source software so that anybody for free can use the same weapons grade statistical software that's used at Google. So we were talking about R before. You know, you can go read about how Google loves R as its statistical software. It's free. You know, you can go use it. Anyone can go use it. And that really democratizes the ability to get your hands on weapons-grade statistical software. Similarly, around 2007 or so, there was a lot of innovation in cloud computing and just really, really cheap hardware to the point where anybody could spin up production-grade computational resources with, you know, a few pennies of credit card expense. You know, so you could go from your office or your dorm room, as people have shown, and spin up what used to be one company's worth of computational hardware without hiring a sysadmin, without any of that. And on top of that, there was already great advances in open source software for doing all the enterprise stacks. So people like to talk about the LAMP stack, Linux, Apache, MySQL, and PHP. As an open source stack, you don't have to pay for it all, and that's enough software for you to run a company. Contrast that with 15 or 20 years ago, where if you wanted to start a company, you need to find the right venture capitalists in the right suburb of San Francisco with the right PowerPoint go out and build, get a bunch of money, hire a bunch of people, and then maybe you could build the MVP. And now, 2014, you can do that in your dorm room in half an hour for pennies or free.
Yeah. Tony, maybe you can talk about, on the financial world, obviously we've been, the advent of Bloomberg and compiling a lot of data sets and having it access to the financial community. You've lived through this and seen it, and then launched Majestic Research. So maybe you can talk a little bit about your history of seeing the use of data and the pros and cons of using open access data and then building proprietary data sets, and how that advanced.
Yeah, I mean, I had worked in finance for 15 years, working for Marty Zweig, a block away, before starting Majestic Research. And Marty Zweig was a great empiricist, and still a lot of the questions that were being answered by us at Zweig and Zweig Domena and by other investors and by the sell-side firms that were selling research to investors were being answered through anecdotes. We sent somebody to the mall to count cars that were parked, or walk the aisles of the Gap and see what percent of SKUs were being discounted, or called 10 store managers and this is what they said about cell phone trends. And having studied computer science at Carnegie Mellon and just always being into math, and my role at Zweig, started out building software to help them test ideas, and migrated onto being part of a research team and the director of the research team. I just felt that the anecdote can be a very powerful way to answer questions, but empirical data can also be very powerful, and in some cases considerably more powerful than the anecdotes. And the thought is that we live in this world today where hardly anything occurs that doesn't leave behind a myriad of digital footprints. And for a while, most of those digital footprints just sat on servers at computers and racks globally gathering dust. And is there a way to harvest the data so you could turn all of those digital footprints into insight and answer questions that used to be answered by trying to call a handful of people or send an intern somewhere, through analyzing large amounts of empirical data. And as technology advanced, large amounts went from meaning 1 million records to 10 million records to 1 billion records to now 1 trillion records of data that you can process on Amazon Redshift in 15 seconds. So.
And did the tools advance as well in the capabilities of acquiring or accessing this data, or is it, did that change to the momentum to allow financial firms to get access to this data?
Well, I think a lot's changed. At Majestic, for us, we wanted to find data that's never been analyzed. So we weren't looking for companies whose business model was selling data. We were looking for companies that were like a software company or something, and we knew that they had a lot of data that was a real asset, and we would offer them money to sell us their fumes, and that was found money. It was serendipitous. Wow, you'll pay me this, and it's pure margin, and it flows to my bottom line. Yeah, here, have at it. That's great. And I think today everyone's savvy, almost to a fault. They have like huge dollar signs in their mind in terms of what is the value of that asset. And so now if you call a company and say, oh, we think you've got some interesting data, have you ever considered selling it? You might hear like, well, let me transfer you to our VP of data monetization. A lot has changed, and people are aware that the data has value. And to the earlier point of, how much data can be stored on a hard drive, hardly anybody's discarding or, the data's stored now because it doesn't cost that much.
Yeah, absolutely. So now I want to get to you on the political side. So obviously we see a sea change in calling elections over the last few administrations, at least the Obama administration. So maybe you can highlight what you've seen in the last few years about the use of behavioral data, in this case voting data or poll data, and how that's really having a seismic change on how we look at politics and getting an understanding of what people think about issues and who they may vote for.
Well, I think social science in general has experienced a pretty overwhelming renaissance as far as public interest in what we do, due to all of these developments. 10 years ago, nobody was watching what political scientists were doing every election cycle. Now some segments of the population are glued to media outlets that are reporting what political scientists are doing. And now the media outlets are hiring in people to do this for them.
Did you ever expect you'd be working for the Huffington Post?
Never in my life. I was going to be a college professor, that was it. But all of the skills that they teach you in graduate school for dealing with data, for dealing with human behavior, for analyzing data, trying to get published so that you can be a tenure-track professor, what better skills are there for dealing with these big, unwieldy data sets that are full of human behavior information? So academics, building on what Chris said earlier, academics are seeing a lot of use for their skills that previously wasn't there. So that's how I've found my way into it. And I think that's happening for a lot of social scientists in general, not just in politics. If you're following kind of the data journalism developments, we have Vox.com, which is Ezra Klein's new venture. We have 538, that's Nate Silver's relaunch. And all of these things are covering data in every field. Like 538 started with politics, Ezra Klein started with economics, both areas where academics have been studying data for a very long time, but now there's such widespread interest in these things that they're putting out full online news organizations to serve the interested communities. So this is a huge shift. Specifically to politics, it's really overwhelmed the election cycles the last few times. There's the public side that everyone sees, all of the polling data, trying to make sense of an overwhelmingly large amount of polls and trying to make that make sense. Which one should you pay attention to? Oh, this one's biased, this one's skewed. What do you look at? And so that's where my focus is trying to make sense of the overwhelming amount of polling data and opinion data that's out there so that people can come to the Huffington Post pollster and see the charts that have been curated over several election cycles. Pollster has been around for quite a while. And get a kind of a one-shot look. Privately, there are huge advances happening within campaigns. You may have heard about Obama's data campaign, where he had this entire team who spent their entire lives trolling Facebook, looking at Twitter, matching people up to voter registration lists, doing polls to find out how people were planning to vote, if they were planning to vote. And then they triangulated all of this together to map out what Obama needed to do to win, and the people that needed to be targeted, the people that were that you could influence to change their minds. And so that work, started by people in their mid-20s, has now launched several companies. Of note, I believe Obama's chief has created, the chief data person through the 2012 campaign has created Civis Analytics. Or that's at least part of the team. There are several other businesses that have spun off of this, because it's just the social science principle of how we deal with huge amounts of human behavior data and the training to deal with it.
Yeah. So being a geneticist myself, how do you, in dealing with that on a personal level and trying to figure out how to identify the true signals from the noise? Obviously, we're dealing with a lot of data now. And are there issues with that in really being able to try to find the value? And how are we dealing with that? Because we are collecting enormous amounts of data. But the value's got to be somewhere, and how do we identify those? So what are some of the solutions, Tony?
I think, the biggest challenge I have when you're dealing with more and more data are the issues of false positives. Like, I'll look at data and I'll go through the exercise. Okay, I know this happened, and would this data have been able to foretell this? And then the answer is yes, and then you get this adrenaline rush and you get really excited. But then, there's 10 other things that the data might have also suggested that were spurious, that were false positives, and that can cause you to make ill-informed decisions. And I think, at the end of the day, we use the term data scientist, but there's a part of that term that's a little bit redundant, right? Scientists, the scientific method, and it has always been about analyzing data, so it's not like all of a sudden this idea of data is new to scientists. It's what scientists do, but we have just a lot more data, and that's going to mean a lot more false positives, but a lot more questions that you can answer. So I think it's got to go beyond just being a great, so-called data scientist, but just really having the passion for the subject matter. I think the same things that made a great scientist are going to continue to make a great scientist. They're going to have to figure out ways to engage with large amounts of data. And maybe you get that training, or it's going to be software. It's going to be more and more readily available for somebody who doesn't have, like, my background, right? And so then you have to say, all right, what do I need to do to mitigate the instances of false positives? Let's figure out, what are these dynamics? What has caused the distribution of some data to potentially change? So what used to be static or normal, stationary normal, is now non-stationary. I remember, at Majestic Research, we were trying to understand the hotel companies like Marriott better by looking at the price online for millions of Marriott hotel rooms at different dates in the future. And if you say, all right, if hotel prices are going down, that's probably means that they're having trouble filling the hotels, and that's negative. And if they're going up, that's a healthy thing. It probably means occupancy's high, and so on and so forth. And we had a really good model. And one day we came out with an estimate, and it was wrong. And the data scientist or the quant who had built the model was like, I don't know, the model just broke down. I can't figure it out. But then if you really get under the weeds and you start reading the K's and the Q's or the conference call transcript, you see that, actually this company used to hedge their foreign currency risk, and then they stopped hedging, or they weren't hedging, and they started hedging. And so you didn't have exchange rates as a variable in your model. And so I think that comes from the passion. And so you need that sort of passion for the subject matter. And it's not just about, being, strong, with SQL or statistics and so on and so forth.
Have anybody seen the article that came out within the last week or so about the hurricane names? Yeah. How women, these people, this is a great example of your kind of false positive and having to know the data. These researchers came out with an article within the last week that said hurricanes with female names have caused more deaths. Therefore, people are less likely to prepare if the storm is named with a name that people perceive to be female. Well, there was a problem with this. Their data went from 1950 to 2012. Hurricanes were only named with female names until 1978. So you have no variation until 1979 when they started adding male names in. And you also have the fact that as time moves forward, prediction gets better, preparation gets better, communication gets better. So yes, people are less likely to die. So it's one of those common sense type of things that if you, and I have to give credit, I did not know about the naming conventions. I have several meteorologist friends who, you know, immediately their heads exploded when they saw this, and started telling everyone that, you know, this is not a real relationship. So you do have to be careful and know exactly what's going on.
Chris, do you have some comments on that?
Part of it is exactly that you need domain expertise, and that's one of the reasons that I think data science will never be replaced by software. So, in fact, John Tukey, the statistician, said this quite explicitly in the 60s, that, you know, there is a necessary human element to statistical analysis. Tautologically, I would just say whatever the thing is that you can replace with code, that's not data science. That's, you know, something else. So you need some human element in order to see if your results make sense. A sort of more boring but technical answer is that a lot of what's happening in predictive analytics is not the same as what's happening in explanatory statistics. So explanatory statistics means looking for correlations like that, putting a p-value on it, and then telling a story. Predictive analytics, on the other hand, usually means taking in, you know, tens, thousands, millions, or in principle an infinite number of variables, and attempting to make predictive statements about data. The way that people then convince themselves that they're not fooling themselves is empirically to test how that model generalizes. So in finance, this is called backtesting. In machine learning, this is called cross-validation. But in general, you shouldn't let your data scientists go loose with production code until you have held out some of the data, built a model, and then seen simply empirically how well does that person's model do on the data that you don't have. That itself sounds like an obvious thing to do, but it's something that's only possible if you have abundant data. I mean, if you were trying to build a statistical model from 56 soybeans or something like that, you wouldn't want to leave out any of the data because you only have 56 numbers. But if you have copious data, sure, leave out 10% of your data. Sure, do that 10 times, do that 100 times. It's an easy way empirically to estimate whether you're fooling yourself.
Are we moving away from intuitive-based decision-making, and really people are forced to look at the numbers?
So there's a drive in machine learning to build models that are both predictive and interpretable. Yeah. So if it's predictive, that's sort of an engineering win. I can use this as a tool, and I can make, you know, I can tell you what movie to watch or something like that. If something's interpretable, that's useful to the domain expert, whether that domain expert is a scientist or somebody in business, and the interpretability of your predictive model may inform future strategic decisions, the kind of decisions that are made around a table rather than in a few lines of Python. Yeah. I wouldn't say that people are moving away from having intuition. People like knowing what they're doing. Yeah.
So I want to, you know, open this up. Does anyone else have questions? You know, we want this to be a common dialogue between our panelists, obviously, and you. So any questions from the audience? Yeah, right here.
Well, this is for Tony. If you had somebody go around the Gap store and try to figure out how much was on sale, how can you do it today with the big data? You still have to get somebody to go through the store.
Gap has an online store, right? Gap.com, OldNavy.com,
yeah, you can't take their stuff.
BananaRepublic.com.
They're not going to tell you what their stuff. Oh.
Okay. Right? If you want to know how much a blue shirt sells for at the Gap, go to Gap.com. They tell you, because you can buy it there. So all that information is publicly available information that's available to anyone.
What about the omni-channels that the retailers are capturing now, where it's not just what's online, it's not just what's in the store, it's everything that they know about you. And the retailers tell me they have 3,000 data points on almost everyone.
Yeah, I mean, that's the world that we live in today. You know, Amazon has made it clear that a lot of people would rather not get up and walk to the store and deal with that, and you know, more and more people are buying online, and you know, omnichannel is the retailer's response to that, because they understand that people might want to, you know, buy things on their desktop or laptop at home, on their tablet, on their mobile phone, and that's the way that retail is going and will continue to go.
Is a real estate owner capturing that data?
Is a real estate owner?
No, the retailer is, but as a landlord, other landlords capture.
Yeah, I mean, I'm seeing a ton of big data in the, you know, at the end of the day, you're going to have people like me that are in finance that are going to have, you know, hundreds of billions or trillions of dollars bet on the outcomes of, you know, certain behavior or decisions. And in real estate, you've got securitization. And you need to understand what underlies those securities. And there is so much information now available about pricing in commercial real estate, and residential real estate, new homes, existing homes, and so on and so forth, that you know, it's, I don't think there's any industry that's not making use of big data.
I'm not sure if this is where your question is going, but that also begs the question of whether or not the landlord has access, has information about potential tenants. And as you know, that's regulated, right? Like, it's regulated that you're not allowed to take certain attributes of the potential tenant into account when deciding whether or not to rent. I think that speaks to, well,
Oh,
like,
you're talking about residential?
yeah.
Rental, oh, well, I'm
Perhaps,
really-
perhaps
oh,
that's not where your question was going.
No, I was really talking about the mall owner.
Okay.
I mean, just found
Yeah.
Shanghai yesterday.
I just wanted to
Yeah.
add a point that now the collection of data is no more just data points such as price information on what you, how much you bought it for, and so forth. There's data collection on channels where you are collecting unstructured information, like the conversations you are having with the other person, live person on the other end of customer service. All that unstructured data, which is not quantifiable in exact numbers, are also being collected, which could be analyzed using various advanced NLP techniques to come up with new personalized recommendations or whatnot.
So, question over here.
Yeah, I like Tony's earlier indication of data monetization.
Could you stand up, sir?
Happy to stand. But I like your idea of data monetization, and I'm just wondering whether, are we now going to see data as an asset class?
That's a good question.
Freedom?
I think so. I met with an interesting startup the other day. You know, it's called Data Coup, and essentially, other companies are making a lot of money right now off of your data, off of my data, off of Eric's data, off of the data of most everyone in this room, and so, who owns that data? Who owns the data of your own behavior? And how much is that worth? And it's a very aspirational goal, to be honest. I don't know if he'll succeed, but the idea of DataCoo is to let you kind of create a locker to collect all of your own data, and then if you decide to make it available to advertisers or publishers or whomever, you can get paid for your data as opposed to any of these other firms in the ecosystem that are currently, like Axiom or whoever else, monetizing your data. And so I, you know, ethically or fighting the good fight of, you know, like, it's my data and I should decide whether or not it gets sold, and I want to enrich myself by selling it. You know, I'd love to see them succeed. I don't know if they will, but it's an interesting concept.
Yeah, I don't know if you want to explore that a little bit more about the rights to data.
No, I mean, it's already a
Do you have any
thing. I mean, there already is a thriving industry in data brokers. In fact, recently there was a 60 Minutes report called The Data Brokers, and you know if it's already in 60 Minutes, then it's been around for a while. So, yeah, that's a thriving industry, people selling data.
Over here. Up.
Hi. Question, I want to get everybody's opinion, if you will. You know, when Edward Snowden was interviewed last week on NBC, he made a comment that the haystack of data that the NSA collects is too big for them to fathom. Is that a fact or a myth, or what's your opinion?
Haystack.
Yeah.
So this gets back to the question of why is data science happening now, and part of it is that data is sort of too cheap to meter. I mean, it's so cheap to store data that it's going to cost you more time to triage your data than it is to just store it and put it somewhere and then look at it later. So, I mean, yeah, if you think of NSA or its corporate partners as people who are ingesting abundant data, including the metadata, including the unstructured data, and just ingesting all of it, storing it, and looking for data for later, then yeah, that's totally reasonable to think about. I mean, that's what many companies are doing all the time, is they store every information about every interaction online, thinking that later they'll go through and find some monetizable pattern in it. It's cheaper to store the data than it is to sort of triage and analyze it right now.
My question is it too much for them to understand? His premise was that they have it, but they don't understand it.
Golly, well, understand is a difficult verb. I'm going to leave that to somebody else.
Yeah. I mean, look, if you think about all of the email that you've got in your inbox, I don't know, anything like me, it's just a monumental amount of data, and I'm one person. So let's just assume, for the point of argument, that the NSA was sitting on top of all the email in all of our collective inboxes. Absolutely, that is, too much data. It's good data, like, oh, I suspect this person might be up to no good. I'm going to go zero in on this person's data. But in terms of like the data mining and sifting through the false positives, because for every real positive, there's going to be 100 false positives, and then keeping in mind that it's the government, and I'm fairly cynical. Absolutely, I agree with his, conclusion 100%.
Eleanor?
Good point about the data being too cheap to throw away, too cheap to sort of, one of the major alternative lenders, I think it's On Deck, was collecting so much data that they couldn't afford the relationship databases, and so they just store the data. When they need it, they pull out the sets that they want to analyze. But I'm interested in finding out from each of you, in what ways is our new awareness of big data, our new techniques for analyzing big data, changing your industry? How is it changing fintech? How is it changing journalism and content and media?
Natalie, do you want to start?
Sure. We've seen tremendous changes in media on several dimensions, and I'm not qualified to really tackle all of them, but I'll give it a little bit of a try. Particularly with online media, it's so easy to know who has clicked on what and what type of stories they're interested in. And it seems that there are developments in place to kind of target what people are reading and what they might be interested in. So I read primarily politics articles. So when a newspaper is coming to try to sell me a subscription, they should show me the quality of their politics articles, because that's where I'm going to be impressed. This is something that I know Facebook is very good at, because I will stay logged into Facebook and go shopping around on the internet or do any number of other things. And then when I go back to Facebook, I will see an ad for one of the exact products that I was looking at. So things like that are trackable. I think on that dimension, there are a lot of openings for media, and certainly they're probably engaged. That's the area that I'm not really qualified.
Nothing to do with big data. We were doing that with direct marketing 20 years ago online. That was what made interactive advertising happen. And yes, the behavioral has become more sophisticated from a technology standpoint. It has nothing to do with big data. What is big data doing to change?
It does, because we have so many more data points now that it's become these huge data sets rather than just what we dealt with.
In the aspect of journalism, has it really changed journalism? So are reporters or someone writing a story, is there demand on them to find as many data points as possible versus the anecdotes or a few supporting elements of that story? Has that changed at all? Do you know?
So it is not yet the case that all journalism is data journalism, but there is clearly a field now called data journalism. In some way, data journalism is to computer-assisted reporting as data science is to machine learning. There already sort of were precedents for this. So computer-assisted reporting has been around for a decade or two, of people trying to find stories in large databases or obtain large databases in order to find some interesting stories. Data journalism, now people are referring to presenting those stories, but also sometimes sharing the code and the data that are created alongside those stories. So 538 and Vox were mentioned. Upshot is also the New York Times crew for data science, for data journalism. So there's a group within the New York Times that's pursuing data journalism, and in doing so, also sharing the source code and the data sets that they're used to create those stories. So sharing source code and data is something that you wouldn't do if you didn't have a World Wide Web. You wouldn't share the source code unless you had high quality open source statistical software that everybody could use so they could reproduce the analysis in that story. So those are new aspects of data journalism. The other thing that's new in journalism is all of Newsroom Analytics. So as news moves from something you consume from dead trees to clicking, whether that's on websites or on your mobile device, everything that you do is potentially trackable. And so there's a whole field of analyzing who engages with journalism, how do they engage with it, how should you be distributing your journalism, how should you promote your journalism. And this is very much of interest at the New York Times. I encourage you to check out a 96-page leaked document from last month written by people in the newsroom about confronting the digital age in journalism. And it's a very forward-looking document about how technology is changing journalism. The title was Innovation Report, I think.
So the company I think that's done the most, I think, to change the way that companies can process big data is Amazon. Okay, so back in the early days of Majestic, which would have been like 2003, if we were getting data sent to us that was, certainly in the terabytes and eventually in the petabytes and billions, if not tens of billions or hundreds of billions of records, we were talking about requiring a huge stack of servers with multiple databases, waiting overnight for queries to run, having a team of DBAs that could help optimize your database structure so the queries can run faster, and it was absolutely painstaking. And subsequent to that time, you had technologies like Hadoop, like columnar databases, such as Vertica, which is Hewlett-Packard, or Greenplum, or Redshift, which is Amazon. And now, fast forward to today, if you or I or anybody wanted to analyze tens of billions of records, you could be up and running on Amazon within minutes, have access to terabytes or petabytes of storage. It's a columnar database, so it runs much faster. Amazon's taking care of all of the security, all of the processing, and you've got SSDs instead of spinning hard drives, which also speeds up how fast you can analyze data. So one person now can query hundreds of billions of records of data in seconds. And that, just the concept of that, and now you've got companies building front ends on top of Amazon, or great companies like Tableau or ClearStory that make it easy for the layman once they're set up to do that really give access to pulling insight from the data to anyone who's got the gumption. So I think that's the biggest thing that's changed, and I give more credit to Amazon than anybody else for making those changes. And it still amazes me to this day when I talk to companies who are going to send data, and I'm like, well, I'd love to put that on Redshift, and like, oh, we don't even put our own data on Amazon because it's so secure. I'm like, wait a minute, you think your security is better than Amazon's, and you're a 200-person company? Like, that's mind-boggling because it's not.
What's the effect of getting more insights from more data? What is changing?
What it is you can answer questions that you could never answer before. You can answer questions more precisely. Look at what's going on in healthcare, in molecular diagnostics, in cancer treatments, understanding a tumor, right? A tumor is not just a breast cancer tumor anymore, right? Everyone's is idiosyncratic and unique, and you need all of that data and the ability.
That's not the real world. That's what she's asking. So all
Why is that not the real world?
Science fiction.
That's not science fiction. That is absolutely, I could not disagree more with that statement. I think you are dead wrong.
It's impacting treatments right now, real time.
Yeah. Samir, did you have something to say about
that?
Yeah. What I wanted to add is to answer your question, what has changed, what has made big data is besides just saying cheaper storage and faster processing power, What has changed is how all of those things have been put together. And a software layer on top of it that makes a lot of things possible that was not possible before on analyzing a lot of data. For example, it's just not cheap storage anymore, but it's the software layer like MapReduce that can allow software to, the algorithms be transferred to each of the CPU nodes and process individual data sets and do put together analysis on top of it. The software layer and all things put together is something that has changed.
So Samir, you started a company in this area. So do you think this field is ripe for entrepreneurism? You know, we promote this sort of ecosystem, and it seems like a topic that there is a lot of data out there. There's a need for domain expertise in these particular areas, so it seems like a ripe industry to start companies and develop. So maybe you can give a little your experience of, is there an appetite for this type of stuff, and are you seeing interest from investors' perspective?
There is definitely an appetite for large companies to look into solutions that does data science and big data on top of their data. There's also definitely interest from investor community on investing companies that are trying to do data science and big data. But one of the challenges as a startup when you're trying to work with large companies to do data science and big data is really working with them and trying to figure out the assumptions they have on what kind of insights they can get from the data. You know, when you're talking with director of customer service who is not dealing day to day with raw data, has all these possibilities and insights that they have in mind, but the raw data could be in a completely different form from which the kind of insights may not be possible. So being able to connect with that is one of the challenges when you're trying to do a startup on big data and data science.
So tell me, when you look at companies, what are you looking for from their perspective? If they're selling you a big data or data science idea.
Am I looking for?
Yeah. What,
I mean, you have questions that you're trying to answer. You know, in my world, it's investing, and I want to understand. There's been a catalyst. You know, something's changed in the world. You know, how's it going to affect consumer behavior? How's it going to affect company behavior? And so I'm looking for data that can help answer those types of questions, so you can help, you know, triangulate an investment thesis. More and more people are buying Tesla cars. What is that going to mean for the broader automotive market? Or you know, companies. I don't know. I mean, another good example of how, you know, big data is being used to change the way a company fundamentally does businesses in the retail space. Zulily, for instance. I don't know. There's probably maybe some moms in the room that are familiar with Zulily because that's their target market is moms. But what you might not know about Zulily is when you go to Zulily.com, after you've gone there for a bunch of times, what you see is tailored precisely to your own idiosyncratic behavior. And that is informed, and they learn it from, you know, what all of their other tens of millions of customers have been doing. And so they've got millions of storefronts. Each one is catered. It's as if, as they will speak about on their investor day, as if Target could have, you know, different products on the aisles depending on who's walking across the aisle at that particular point in time and everything that they know about that person. And so, you know, these are the types of questions that you can answer with data today that you couldn't several years ago. And you know, I don't think the questions that we try to answer as investors are any different from the questions that people in industry are trying to answer, because it's, you know, they're trying to grow their business and we're trying to understand whether or not they're going to be successful in growing their business. And so it's the same fundamental questions.
And how's politics going to change? So are we going to really see a change in how elections are run, or how events leading up to elections are organized?
You know, the 2008 and 2012 Obama campaigns were kind of the beginning of the idea of a data-driven campaign. And those will continue to expand because there were uses for it. It did prove to be a useful tactic for targeting where to put your resources. as far as actual impacts to the average person, I'm not sure we're going to see much in the near future, because really what the data sources that we're seeing develop in politics are able to do is help describe why people do what they do, why they vote the way they voted, why this person might win. There are a lot of reporting tools that are happening. There's a lot more information going out through the media. There's a lot more communication going on with academics who have been studying these things for decades. But as far as an impact on everyday people, our system of politics is pretty well ingrained, and I don't know that I see big changes happening there. Where the changes are is on the inside, and how people can leverage the information for political use.
There has been politically extremely targeted emails and messages to people. So right. One thing that you saw, or one thing that happened in the last campaign was, I can't remember who had this project, but somebody was running this project that's just encouraged citizens to forward to this one centralized member of the press right. any emails they got, and then sort of reverse engineered what the algorithm was that was predicting which highly targeted emails were going to go to which people. So you could sort of build a classifier that said, okay, clearly this campaign had sent this particular message only to white males in Delaware over the age of 60 or something like that. So there already is some pretty sophisticated outreach to citizens at a level of granularity you can't do with just a television commercial.
One last question for me before we take it off to the audience again is, obviously my day job is working for a very large public university, and we think about STEM education often. And obviously as things become more data-driven, do we have a problem here, particularly in the U.S., with the level of math understanding, computer science understanding?
I mean, there are myriad problems. The problem with statistical education is really a drop in the bucket with respect to the overall STEM education. Yeah. I mean, I would like it if statistics and probability became more had more primacy in the standard curriculum. You know, I feel like, big fan of calculus, but calculus, sort of like was the thing that you needed to do post World War II, and sort of like the curriculum in mathematics got ossified. It's possible that maybe we should start teaching people statistics, probability, or some basics of how to code earlier. Maybe.
I adjunct teaching statistics to college students, and you can only get so far in one semester. But the selling point, I tell them, they're almost always freshmen. They walk in, they've heard horrible things about statistics. It still has this really bad reputation, and of being difficult. And I try to make the pitch to them on the first day. I think I used the article that says data science is the sexiest new job. I make this pitch to them on the first day that to function in the world today, you really have to have some sense of dealing with data, because it's everywhere, and that's not going to change. So the basic concept, if they walk out of there with nothing else, I want them to have some clue of how to function in a world that is surrounded by data, and how to assess claims. Of particular application to big data, one of the things I tell them is that I press on throughout the semester is the larger your data sets are, the easier it is to find relationships and find things that look like they're causing other things. For example, if I have a database of 1,000 cases, and I want to say if somebody who's half a percentage point ahead on a poll is going to win, I can only be about 70% certain that half a percentage point is an actual lead. If I have 100,000 data points, basically at that point, even that half a percentage point becomes basically, the computer calls it 100% certainty. I don't like that, because in statistics there is no complete certainty. But it basically goes to an almost certain thing. And again, that also comes back to knowing your data. Do you want to make that claim? But you have to understand that when your data grow, you find more relationships in it.
Dick, do you have a question?
Yeah, I'd sort of like to get views on what kind of market ecology is developing in big data, and both, you know, human-created big data and Internet of Things created big data. And sort of the model I'm talking about of an ecology is with market data, you get, you know, stock trades from all the exchanges and all the sources, and it's basically available to anybody. And then you can get services to view that data. You can get analytics to analyze it in all different ways. And there are different companies in all parts of that space. So there's a division of labor. So with big data from people and from Internet of Things, is there a data utility? Is anybody trying to build this data utility? And are there people building analytics that you can run against that data to solve problems?
All of it. All of those things are happening. I mean, there's companies that are, you know, monitoring your thermostat and then giving you, you know, dashboards about how you're using energy and trying to make actionable suggestions about how you should change your energy usage. There are data brokers, as we already talked about. There's all sorts of companies like Palantir that are trying to find patterns in data. There's all of high-frequency trading, which you wouldn't be doing if you didn't have some statistical analysis of time series. I mean, it's high-frequency meaning a more rapid time scale than a human being would do, right? So you're doing it computationally. And then in addition to everyone who's profiting directly from data as a first-class object, there's this sort of effect of, you know, if there's a gold rush, you can sell shovels. So there's all these people selling pickaxes that are the tools that allow you to find patterns in data.
But doesn't it mostly bring your own data? I mean, there's lots of tools in analytics.
There's also people selling data and people building tools to help you analyze your own data, but also people selling data. That's the data broker phenomenon. So
anyway,
I mean,
sorry.
there's a very rich ecology.
Any questions on this side?
Interprets. So what are other examples that you can think of how the role of expert changes?
So I got a master's in computational finance, and a big part of that curriculum was something called stochastic calculus, which is just a calculus of a random variable instead of a discrete variable. And back then, that was how derivatives got priced, was you had a PhD who had a good understanding of stochastic calculus, because stocks, like in physics, followed a Bayesian process as far as how they moved, and they could create elegant solutions that would take a little time, but would say this is what this derivative's worth. And then, as you had computers process data much faster and the readiness and availability of large amounts of data, everything started moving from that elegant solution to the brute force solution. Well, there's only several million possibilities of what this can do, so let's just run all of those in seconds and see what this derivative would be worth, you know, at the end of all of those millions of paths, and take the simple average, and that's what it's worth. So we don't need that, you know, expert anymore. We just need somebody who can run these Monte Carlo simulations. And to a certain degree, that's what happened with chess. When I was at Carnegie Mellon, we were developing, you know, Deep Think that became Deep Blue, and IBM acquired it, and ultimately, as most of us know, defeated Kasparov. And it wasn't really that steady state algorithm where you tried to say, what does this position on the chessboard mean for the white pieces versus the black pieces? It's not that some expert improved that. I'm sure it got improved, but more glacially. It was that things could be processed that much faster. And so the expert, you know, it's a philosophical question as far as what defines intelligence. I was talking to somebody who's a partner at one of the largest hedge funds in the world that does everything quantitatively. It's all systematic trading, large data sets, and they believe philosophically that companies like the company I work for now will ultimately be driven out of business because the experts are going to be inferior to, you know, the computer in terms of making those decisions, just as like the experts in chess became inferior to the computer in making those decisions as far as what's the best chess move. Now there's a big difference that the world is not discrete. There's an infinite number of things that can happen in any moment in time, right? But at the end of the day, I didn't really want to argue against them that 20 years from now, almost all investment decisions will be made by the computer with the human maybe guiding it a little bit. And so I think that, it's a philosophical thing to be debated about what defines intelligence, and it's just an interesting thing about what it'll mean to be an expert.
We are running out of time. I do want to allow you guys to network a little more. I want to give a great thanks to our panel. I thought they did a fantastic job. I want to thank our organizing partners, the Licensing Executive Societies, New York City chapter, as well as obviously our sponsors tonight, K&L Gates, for this location and the wonderful reception. I guess I have one last question for our panelists, yes or no? Do you find what you're doing sexy?
Oh, yeah.
Yes. Samir?
Yeah.
Chris?
Better than sexy.
Excellent. All right. They'll be around for the rest of the year until about 8 o'clock, so catch them now or in the reception outside. Thank you all for coming, and thanks for the wonderful questions.